mechanical engineering, and I'm also inclined towards the field of materials, engineering materials. Like I have chosen my topic similarly, that is polymer nanocomposite, and I have my personal inclination towards composites and fiber reinforced composites, polymer nanocomposites. So that's why I chose this topic, so that students can have a little means information about this novel material. I have chosen the term novel material because it is the material of the demand right now. Right now, in industry, we need to have such kind of materials because already we are having different types of materials, but different types of materials are having their own pros and cons. Some positive points are there, some drawbacks are there. So ultimately, for engineering requirements, we need to have some novel materials which should have a better properties. Basically we want to have enhanced properties, and then we go for the such kind of materials, out of which one is the polymer nanocomposite. Anyway, I have done my um, master's degree from Motilal Nehru National Institute of Technology, Allahabad, Prayagraj, India. That is an institution of national importance in India. And I've done my Bachelor of Technology from Government Engineering College, Uttarakhand, India. So that is also governed by the government of Uttarakhand, that is a state in India. And my project during the my graduation was related to micro hydel power plant, that is producing power in a small scale through hydroelectric. So that was my project during that time. And after that, in the masters, I have done my thesis related to this polymer nanocomposite itself. So my work was related to the simulation of polymer nanocomposite material, its analysis on a software, that is ANSYS. ANSYS I used. So my interests are to travel different places, to cook and explore new things, new technologies, new places, and so many more things. And I'm also spiritually inclined. I love spirituality, and I just want to go for spirituality, means spiritual learning in the coming time also. And I'm right now also I'm doing this thing. So I think all of you are able to listen to me clearly.
Yes, we do. It's very clear.
Fine, and it is visible also, I think.
Okay, so thank you, Mr. Gaura, for your introduction. So just for your information, in this class, we also joined by our faculty member from the mechanical engineering. We have our coordinator of study program, Mr. Pasa Nugraha. Maybe Mr. Pasa can say quick hi. Mr. Pasa,
Hi, sir.
and also some of the lecturer here. So we have Mr. Wiratmaja, Mr. Gede Widayana here.
Good afternoon.
Yeah, good morning, sir. Good morning.
Oh, good morning.
Actually,
In
here
India.
in India, it is morning right now, and in Indonesia, it is afternoon.
What time is it in India right now?
It is 10:30, 10:40 right now. 10:40 in India.
Okay.
Yeah.
Yeah, it's 1 p.m. here in Bali, so just after
Yeah.
lunch. Okay.
That's right.
So I think we will have a very excited material today for our class. So
Yeah.
without further ado, let's extend our warm welcome to Mr. Gaurav Pen. And Mr. Gaurav, the virtual stage is all yours.
Yeah. Thank you. Thank you so much. Thank you to all the audiences. And I hope it will be exciting and some knowledgeable for all of the students. And good thing is we are having first year, second year students. They must know the basic things. So I will start from the basics, and then I will go for the little inside of the polymer nanocomposites. And I have prepared as per the first year, second year, or means undergraduate students itself. So I hope that I will be able to convey my thoughts to the students. So I'm just about to share my screen. So are you able to see the screen?
Yes. Yes, we can
So
see
now I
the
think it should be
presentation.
visible.
Yeah.
So anybody of you can take the screenshots in between of some means of this event.
Excuse me?
I just wanted to have some screenshots in between. So can anyone take the screenshots in between?
Yes.
So I will need some screenshots of this event also because of memory as well.
Yes. I will take some screenshot during your presentation. Don't worry.
Yeah, sure. Thank you. And I will recover them from you later on. So again, good morning, all of you. And my topic is polymer nanocomposite, and it is a joint program with the aid of the Ganesha University in Indonesia, and I'm from GLA University, Mathura, India. And the topic is polymer nanocomposite. That is a novel engineering material. Novel means it is the latest, we can say, state of the art material, because in many places, in many sectors, we need to have materials with some required or desired properties. That too, under some conditions, we need to have very high tensile strength at some places. We need to have very high fatigue resistance at some other places, and so many properties. Or we need to have a good ductility in some places. Likewise, we need to have different properties which are desired by us for a particular application. So similarly, we are having this material, polymer nanocomposite, which is having some specific properties which otherwise in a means base material, these properties cannot have. So polymer nanocomposite can induce those properties in a very significant manner. So that's why I have said it as a novel engineering material. So that is the reason. So I'm working in Department of Mechanical Engineering itself in GLA University. Now the contents. So these are my contents: composites, polymer nanocomposites, industrial applications of this material, futuristic aspects, and what are the challenges in this, how the enhancement is observed. A case study I have taken, that if polymer nanocomposite is taken into consideration, then how we are getting the enhancement in the properties. That I will come in the coming slide. What is the enhancement and what is the things. So I hope it is audible and clearly legible to all of you.
Yes, we can see it clearly.
Yeah. If any issue will be there in between, maybe some interruption may be there in network or something like that, you can nod me, you can tell me.
Okay, noted.
Yeah. So coming to the first thing, first is composite. Okay. So yeah. Composite is the, we can say, if we are having a base material and it is having certain properties, and we want to have better properties, enhancement in the properties. So we are going to have the mixing of two or more materials. Like we are having a base polymer and we are going to have better tensile strength than the tensile strength of this base polymer. Then obviously we are going to mix some other material which is having a better tensile strength than this base polymer. So this mixture of two or more materials to obtain the desirable properties is known as composite, if we talk about the definition. So concrete, I have taken the example here, concrete. Concrete is the perfect example of a composite. Concrete is a composite. All of you know what is a concrete. We are having cement mixture and then we are having some reinforcements in the form of some, we can say, stones, some means big particles, big grains, and they are going to enhance the strength of this cement mixture. Especially the compressive strength is enhanced. So concrete is the perfect example of a composite material, and it is a non-homogeneous mixture, obviously. Otherwise, if you are going for a means alloy, generally there is a discussion that alloy versus composite. So alloy is we know that it is a homogeneous mixture of two different metals. But composite is not related to only metals. It can have non-metal. It can have, generally it is having inorganic things or non-metallic things. So that's why I have taken the best example of concrete here. That is a non-homogeneous. You can see concrete. It is not exactly having the same composition everywhere. Okay, similar composition everywhere. So that is composite. So alloy, we can have the same properties along the alloy. Means if we are going to check the properties at the micro level or at a small level, so we will get the same properties at different points of the alloy. But at composites, we can get different properties at different points or different sections of the composite material. So that's about the composite material. Now coming to the nano composite. So composite, obviously we are having some base material, then we are mixing some reinforcement material. Obviously the new material which is being added is known as a reinforcement, and the base material which we are adding some material, that is known as the base material. Okay, so I think the first year and second year students are able to get this what I want to convey. So base material and some reinforcing material. Reinforcing means which is going to contribute for the properties which we want to have in that material. And the good thing is we can go for getting the properties in any field. Like mechanical properties can also get enhanced, physical properties can also get enhanced, chemical properties can also get enhanced, optical properties can also get changed as per our desire. So we can go for different segments of properties during our preparation of the composite and nano composite. Today our topic is more about nano composites. Okay, so what we are having in nano composites, you can see in the slide. We are having a polymer matrix. Okay, and there are nanoparticles. You can see here. So it is, again, we can say it is a mixture of two or more materials. It is also the mixture. Okay, but now the mixture scale of the mixing, what we are going to mix, what reinforcement we are going to mix, the scale is different here. Earlier in a composite, we were going for simply mixing some fibers, some sheets, some laminas, some particles, irrespective of its size. Means there was not a particular limit of the size, that what size we are going for. Okay, like in composite, we are having the grains of bigger size, and the size is coarse, and it is not very even. We cannot say that this size is having this particular limit. So that was composite. It was means not having any particular size range, exactly fixed size range. But in nano composite, obviously the name itself is telling that we are going to mix some inclusion material or reinforcement material in some base material. Okay, generally base material is a polymer. All of you know what is a polymer, and in that we are going to enforce or mix some inorganic material or metallic material or some other material, whatever material properties we need to enrich in the base material, that material we are going to mix. But we can see in the first line a base material is there. Okay, or polymer or a matrix, also known as matrix. A filler material which we are going to mix, that is inorganic material, or reinforcement or inclusion, all are the same terms. Okay, but these reinforcements are in the form of a nanoparticle here, or nanofiber, or nanotube. That is the difference between the composite and nano composite. Here the size scale is coming to nanoscale, and nanoscale, all of you know, that is around 10 nanometer to 150 nanometers or 200 nanometers. That should be the size range of this reinforcement which we are going to induce in the base material. Okay, so 10 to 150 nanometer particles we can mix, or we can go for the fibers. We can mix the fibers, we can mix the sheets, thin sheets of around 100 nanometer thickness. So if these will be mixed in the base polymer material or base matrix material, then a peculiar phenomena happens. Like obviously base material will be having some properties, some elastic modulus, some tensile strength, some Young's modulus, some Poisson ratio, and so many mechanical properties we know. Okay. Similarly, this nanoparticle, whatever nanoparticles we are taking, that material is also having some properties. Okay, like tensile strength and whatever I talked. So obviously, if we are going to enhance some property, suppose I have to enhance the tensile strength. So the base material is having X tensile strength. So obviously, I need more than X tensile strength. So obviously, what kind of material or reinforcement I will be adding, which will be having more tensile strength than the base material. That is a very basic fundamental. Okay. So this kind of material is added into the base material in the form of some nano particles or nano fibers or nano tubes, nano surfaces, nano sheets, etc. On doing the process in a particular defined manner or in a particular technical manner, we are getting the nano composite finally. Okay. A nano composite, we will find a rich enhancement, a very high enhancement in the properties. That is observed. Okay. And how it happens, you can see in the diagram. There is a polymer matrix, this green one. This is the base material. And there is a nanoparticle. Some nanoparticles are shown here, 3 nanoparticles. Okay. So when the nanoparticle is mixed with the base polymer, then there is a formation of an interface in between the two, polymer and the base material. Sorry, polymer and the inclusion. There is a formation of an interface. And the interface plays a very big role because in this interface, the properties are going to vary because inclusion is having some property and polymer is having some other properties. So this interface is we can say interface in between the inclusion and the polymer, and it is having a variation in the properties here. So suppose it is having Y property, the yellow one, and it is having X property, the green one. So obviously the properties between in the red zone will be a little different. It will be in between X and Y. Okay. So that is a very interesting area, this red zone. It is known as interface or interaction zone. Okay. And the nanoparticles and polymer. So now we can move ahead. So these are the different types of nanocomposites. Suppose we are adding nano sheets and polymer, then also we can get some polymer nanocomposite. These are layered silicate sheets added to some polymer. Then inorganic material is particles are added to the polymer. Then we have got another polymer nanocomposite. Obviously, the basic factor responsible for the formation of nanocomposite is how much surface area of the particles is coming in contact with the base material. So more surface area will be coming into the contact, more enhancement we will be getting in the properties. So this surface area enhancement is done by formation of nano entities, nano sheets, nano particles, nano fibers, and obviously we are getting up very good, very enhanced properties in the in this procedure due to the phenomena which we will be going to study ahead. So interface plays a big role in this concept. So these are the formation process of nanocomposites. Traditional method, that method which is being initially started for formation of nanocomposites. And second is bio-inspired concept. So obviously, if traditional method we are going to mix, that is true for composites also. If we are going for a fiber reinforced composites, and if we are mixing the fibers randomly, then obviously it will not be forming. It will not be having that much of good properties as we desire. But if rather we are going to organize the fibers in a better way in between the matrix, then obviously in the whole entire matrix we will be getting better properties enhancement. Okay. So that is true for nanoparticles also. If nanoparticles are scattered uniformly along the base metal, or the nanofibers can also be there. If these are scattered in a better manner in the base material, then we will be getting better enhancement and uniform properties along the nanocomposite. But if these are not mixed in a proper patterned way or fashioned way, they will not be having that much of effectiveness of the properties, or we can say we can get inhomogeneity of the properties along the whole object or specimen. So we can see this. So there is a case study how the interface behaves if we are going to mix a nano reinforcement in a base polymer. Then there is a case study. Sir, I need charger. Just a minute, just a second. Yeah. Sorry for the interruption. So here, what in this case study, what I am going to show to the students, that how the inclusion is going to induce the enhancement in the properties of the material, base material. Basically, this is happening in the nano composites, that we are getting very high end properties. Any property, whatever property we are going for, we are targeting. Suppose tensile strength, then we will get better tensile strength in the nano composite. Suppose we want hardness, then obviously we'll be getting better hardness. Suppose we want toughness, then obviously we will be getting better toughness. Okay. So enhancement of any property can be done by the concept of nano composite, polymer nano composite. And the applications of this are, we can say, numerous. Very big number is there. Like in the field of aerospace, in the field of medical implants, in the field of so many fields, we can find out the applications of nano composites. So in this case study, I have taken a unit cell of a polymer nanocomposite. Unit cell means the basic cell which we can take for the study and analysis of a nanocomposite. So in the software also we can do the analysis. Okay, this is related to a software analysis that is done in ANSYS platform, ANSYS software. Okay, and through the software we came to know that how the properties are getting enhanced and what is the behavior of the interface. So this thing I am going to present here in this presentation, in the coming presentation. Okay. So material specifications, whatever materials I have taken to have the simulation in the computer, in the ANSYS software. So I have taken the polymer matrix as polypropylene, inclusion as aluminum. Okay, polypropylene is having different set of properties and alumina is having different set of properties. And the properties are mentioned here. The Young's elastic modulus for the polymer matrix is 1.5 gigapascal. Okay. And the elastic modulus of the inclusion alumina is 390 gigapascal. We can see what is the difference. There's a big difference, huge difference. And that is the reason that if we are going to mix this 390 megapascal, then we are going to get a very enhanced property in the polymer. Okay. And the good thing is we have to mix the inclusion in a very small amount. It is not required that we have to mix it is in a very big amount. Due to the nano phenomena, small amount scattered in nanoforms is sufficient to enhance the properties. So we have to mix very low volume fraction and still that will do a good work. Okay, it will get a good output for us. So this is the elastic modulus of matrix and the inclusion. Huge difference we can see. And Poisson ratio of polymer matrix is 0.42 and the Poisson ratio of inclusion is 0.21. This is also different for both. Okay. Now unit cell, obviously for software analysis or ANSYS analysis, we need to have, consider a unit cell. So unit cell is based on literature, some literature study and literature review caused me to take this dimensions of the unit cell. So unit cell of this square shape unit cell is taken, which is having 200 nanometer edge. The side of the square is 200 nanometer. And this is the unit cell in which inclusion is shown. Inclusion diameter is of 40 nanometer. And as I told you that when the inclusion is mixed in the base polymer, there is a formation of interface. Interface is a peculiar zone in which the properties are going to vary. Okay, like matrix is having some property, inclusion is having some other properties, and interface will be having some other properties. So it will, this phenomena happens. This is a very observed phenomena in between. Okay, and so in this 200 nanometer is the size of the unit cell, also known as representative volume element. It is also known as RVE, representative volume element. Okay, so it is representing the whole object in a very small form. So that's why it is known as representative volume element. Inside there is a nano inclusion of 40 nanometer. Okay, nanoparticle size is 40 nanometer. In the next slide, it will be shown in the diagram. Then 3 interface layers are taken into consideration. 20 mm each is the thickness of the layers. I will show you the, this is the thing. So in this is one is the inclusion, and this square is a matrix. One is inclusion, and 2, 3, 4 are the interface layers. 2, 3, 4 are interface layers. I think all of you are able to see this. You are able to see this slide?
Yes, we can see your diagram here.
Yeah. So what happens now?
Hello, sir. Can you hear me?
Yeah. I'm able to hear you.
Okay. Okay.
If any
Yeah, we
issue
can
is
see the
in between,
diagram.
you can ask. If anything is in between, you can ask.
Yes, thank you.
So this is the dimensional specification of this unit cell. Then I told you that there is a variation in the properties in between. As we have included the inclusion, we have filled the inclusion in the base material. Then in the vicinity of the inclusion, in the interface, there is a variation in the properties, and that variation is very peculiar thing. It is a the research is going on in this, that how the variation happens. So from the literature, it was found that variations can happen in many ways. So some ways are in parabolic way and some are exponential way. So I will tell you both the ways, how exponential variation happens, how parabolic variation happens, and what is its effect on the overall properties of the nano composite, or we can say unit cell. Okay, so generally 2 types of variations I have taken here. Otherwise, many variations can happen in this if you see the research or literature. So first one is exponential variation. Second one is parabolic. So first one is exponential. So we can see this is inclusion 1, and outside the square is the base polymer, and 2, 3, 4. These are the interface layers. Interface means vicinity of the one, whatever the layers are forming. So obviously what happens, one is having some properties and base polymer is having some properties. So 2, 3, 4 will be having different properties. So it was observed that these properties can vary in an exponential manner. Exponential, we know e to the power x. So if we are moving from this center to outside, so the properties will vary e to the power something like that. So this is exponential variation. Okay. So outside the property will be different at this base polymer, and inside this is different. In between the variation will be exponential. So this is showing the variation exponential from as per the distance from the inclusion particle, how it is going to vary. Okay. So we can see in the next slide how it is going to vary. It is the representation only that it is varying exponentially in this diagram. It is only for representation how it is going to vary. It is varying exponentially in this case. Okay. In the second case, it is varying parabolically. Like material properties are varying parabolically as we move from the inside center to the outside base matrix or base polymer. So I think it is visible or not, the black text? I think it is less visible.
Yeah, can you maybe put a white
Mm,
text if it's possible?
I will try. Its color has become black actually. It is done by mathematical analysis itself, mathematical modeling, we can say. Okay. So I will tell you the equation. If it is not legible, I will tell you. Okay. So the equations which are developed for the exponential variation, that how the exponential variation will cause the change in the properties. So for that, it is found that the property will be varying in this manner. Suppose nu is the property of the particular interface at any point of the interface. So nu will be equals to nu m. Nu m is the Poisson ratio for matrix. E to the power t upon t ln nu I upon nu m. That is the property. I will actually, it is not clearly visible here. So nu equals to nu m into e to the power t by t ln nu I upon nu m. In this manner, mathematically, it was found, mathematical modeling came to know that in this manner, the properties are going to vary in the interface layers. Okay. Similarly, E will also vary like this, the Young's modulus or elastic modulus. E equals to EM. EM is the matrix elastic modulus. E to the power T, T is the small t upon capital T. ln E of inclusion upon E of matrix. So T means distance from the center. This is the center of the inclusion. The distance from this is T. And capital T is the overall total distance. Total distance from this to outside layer of the base metal, base material. Okay. Or we can say it is half of the length of the edge, 200 meter, 200 nanometer. So it will be 100 nanometer. So I think you are able to understand or not.
Yes, I think technically for the student, maybe they don't really understand it yet, but I
Yeah,
think they get the gist, I think.
first year, second year students may anyway, I will try to make it. Oh, its colors also. Let's wait for 1 second. I will just actually color has been. I changed the color, but it has not got saved actually. That's why it is now not visible. I just a minute. 1 minute I will take.
Yes, no problem. But I think you can try change the background, especially just specific to that slide, maybe.
Yeah,
That
yeah,
may
yeah.
can help.
I will try to do this.
While you do that, I would like to remind some of the students that joined to this classroom today, please open your camera so I know that you're listening to the guest lecture. Oke, silakan buka kameranya, rekan-rekan mahasiswa.
Izin Ibu, sinyal saya sedang ada kendala karena sedang di luar daerah kos dan kampus. Jadi saya mohon maaf tidak bisa menghidupkan kamera.
Oke, yang nggak ada kendala sinyal, silakan buka kameranya. 3, 2, 1. Oke, better. Please, Mr. Gaurav, continue. Thank you. Excuse me, I think you're still on mute, Mr. Gaurav.
Sorry. I was speaking and I was on mute. Sorry. So I think I started from the basic so that they can understand what is a composite and what is a polymer composite and what is a polymer nanocomposite. Okay. So the students of the first year and second year should be able to understand what is a composite at least, and what is a nanocomposite then, and what is a polymer they already know. So these things at least they should know. And what is happening in this, that I am going to present here, that what kind of enhancement or change in the properties in the positive direction we are getting. That's the topic of mine. Okay. So I think now it is legible. We can see it. Actually, previously I edited that, but I think it was not saved properly. That's why there was a disruption here. So sorry for this. So now you can see this, how the Poisson ratio is going to vary along the from the inclusion center to the outside base polymer in this direction. Okay. So you can see nu equals to nu m e to the power t upon t ln nu I upon nu m. When nu m is the Poisson ratio for the matrix, t is the distance from the center, small t is the total thickness. Okay, total distance, maximum distance, and rest of the things you know. So similarly, elastic modulus is also going to vary. Okay. Then these are the properties of the interface calculated by this mathematical model, how the properties of the different interface will be obtained. So you can see, just a minute. So you can see the inclusion is having Poisson ratio 0.21, Young's modulus 390, and the polymer matrix is having 0.42, and the Young's modulus is 1.5 gigapascal. So huge difference between the Young's modulus. In between the interface layers, how the variation is happening with this mathematical model, what results we have obtained, we can see. This is 0.374 in the layer 3, layer 2, and layer 1. So we can see the difference. And similarly for this Young's modulus, 3.79, then 24.18767, then 154 gigapascal. Okay. So this is along this direction for exponential variation. This is the center. Its Young's modulus is mentioned. Then layer 1, layer 2, layer 3. Their values are calculated based on this mathematical model. Okay. This was obtained. Similarly, for parabolic variation, also the properties were calculated. So for parabolic variation consideration, the variation was like this. Obviously, we have to develop a parabolic equation that it is varying parabolically. So parabolic equation led to this kind of equation. So nu equals to this is the parabolic variation equation outcome which we got for this case. So according to this, what are the variation in the properties? These are different. Okay. So here we can see the values are different than the exponential variation. So the variations may occur in a different manner. It is a very peculiar thing. It is a very means we cannot ascertain what kind of variation will happen in which case. So, but we can, on the basis of literature and on the basis of observations, we can assume that this kind of variation can happen, or this kind of variation can happen, or likewise. So, two variations I have taken into consideration here. Now, this is the mesh model of this unit cell. So, this is the inclusion inner blue one, and this is the base matrix, polymer matrix, and these are the interface layers shown here. Okay. Then meshing is done in the ANSYS software. So this kind of mesh we have got. Then some boundary conditions will be applied on this. Actually, we have to do the simulation of this particular polymer nanocomposite representative volume element in the ANSYS platform. So actually, we have to apply the boundary conditions. Means all of you undergraduate students must also be knowing what are the boundary conditions. What values are, means what kind of force we are applying to we are going to apply on that particular body, that defines the boundary conditions, or what kind of constraint it is having. Constraints, all of you know what are the constraints. So everything is having some constraints. It is stopped from some side, means some motion is constrained. Similarly, many things can be constrained and many things can be free to move. Okay, so these are the boundary conditions. So here we can have two types of boundary conditions: basic boundary conditions, simple boundary conditions, periodic boundary conditions. Both on the application of both, we can see how it is going to behave. These are the simple boundary conditions when applied on this particular representative volume element. So these are the parameters of simple boundary conditions. Okay. So motion, it is shown here. So in which direction the object or this matrix can move, that is shown. Ux is equal to 0, means there cannot be any motion in x direction, and in y direction it should be freely be movable. Okay, then different nodes, for different nodes it is shown. For the left side nodes, x direction motion is constrained and y direction motion can happen for the left side nodes. And for lower left as nodes, both x and y is constrained. Lower left as means from this side, this is fixed in both the directions. For bottom side nodes, it can move in the x direction. It should be like that. In y direction, it is constrained. For top side nodes, these are the boundary conditions. Okay. And these boundary conditions are applied in the small strain conditions, small strain case. That is again observed from the literature, that whatever the researchers have done according to that. This is again the representation of the same. Second is periodic boundary conditions. So in the periodic boundary conditions, this will be the mathematical presentation of periodic boundary conditions. In this manner, we will be applying the boundary conditions to the RV, representative volume element. Then these are the equations which we have to input in the ANSYS software. For this, we will be needing the knowledge of ANSYS. So any students work in ANSYS in first year, second year?
No, actually here we're not really familiar with ANSYS in this for this year, the first and the second year. So for me, myself, I have a background in civil engineering, so I just helping with the guest lecture today. Myself also not really familiar with the ANSYS ANSYS software, but I think it has the same concept as the finite element, any finite element analysis.
Finite element analysis, the same.
the
Finite
same.
element
I
analysis.
usually
It does the
use
finite
shape.
element analysis.
Yeah, yeah. I think I
Anyway,
get the concept.
yeah, correct. So actually, I thought that third year, final year students might also be there. So according to
Mhm.
them only, I prepared. So anyway, next time also we can have a discussion or some lecture in which I will go for more relevant topic for first year and second year. I was not aware about the first year students will also be there. So
Yeah.
I thought pre-final, final year students may be there.
But that's okay. It's a new information for them. So this is one of the opportunity for them to learn about the new software, maybe.
Yeah. So ANSYS for the first year and second year students, ANSYS is a software in which we can have the simulation or the analysis of any particular physical condition in the system environment itself. So if we have to do any analysis of any means machine, suppose any automobile component, we have to analyze that before launching into the market. We have to go for the analysis because otherwise it will not work. It will fail. So first we have to manufacture that part. That can be one option. Manufacture that part and that use that part in the real life application, and then check at up to what condition it can bear the situation. It can be one type of means way to design the things. Okay. So in this we have to create or we have to form that thing, and then we have to apply this, and then we will be getting the output that yeah, this will be the material, this material will be sufficient, or it is not having sufficient strength, so we have to go for a better material. Then next material you will choose, then another part you will prepare, and then you will check it in the real basis. So that is a real means real analysis. But if you are going for the real analysis every time, so you can think that you have to produce the part and then you have to go for the analysis. That will be taking a lot of time. So it will waste our time. We cannot get the means productivity as productivity is expected by us. So that's why we can go for the simulation in the computer. Simulation and analysis in the computer itself. So in the computer itself, we can do the analysis by ANSYS software. So whatever physical analysis we are going to do, now the physical thing we can make this create environment in the computer itself. That what are the real time conditions, real time forces, real time impacts, real time other whatever conditions may be there. The real time conditions will be applied on that body in the computer itself, and the body will be designed in the computer itself. Suppose like this RV is the same example. RV is the representative volume element. I have assumed this is a part of that nano composite having 200 nanometer size, 200 nanometer size square. So that I have assumed, and it is having inclusion also, nano inclusion. So the real thing I have assumed here in the ANSYS software, and then I'm going to do the analysis of this part, and whatever the real conditions will be there, real situations, real force, real, those are applied in the form of these boundary conditions. Okay. So all the material information will also be included in this. What is the E value for inclusion? What is the E value for the matrix? What is the new value Poisson ratio for both? So these things will also be included or inputted in the software ANSYS. So ANSYS is having all means flexibility, that all the information you can enter in the ANSYS software, and all the real time situations you can create in the system environment itself, and it will give the answer, it will give the solution that in this situation on in this environment, in this condition, how the part is going to behave. So that is the work of ANSYS. That is, we can say, simulation. Okay. Simulation and analysis. So both things ANSYS can do. So I have a suggestion for the first year and second year students. So in the coming time, you can also learn ANSYS software and do the analysis of the various components which you are going to design yourself. You can do the analysis yourself. Okay. So in the coming time you can do this also, and it will be very beneficial because industries work on ANSYS. So many industries, automobile industries, aerospace industries work on ANSYS. They do analysis in the system. So this is the equations we are inputting into the ANSYS in this manner. So then the results which we got from the ANSYS, they are mentioned here. In ANSYS, we applied the forces and the situations in the RV. Then obviously ANSYS will give the results that in this condition, how the polymer nanocomposite will behave. Okay. So obviously when we will be getting the properties, when we will apply some forces or we will do some tensile test, compressive test, or any other test, then only we will be getting the properties. So in the NSYS, we have not done the test, but in the NSYS, we have created the conditions, and finally we have got the results. So these results are like this. In exponential variation case, the stress value is this and the strain value is this. In parabolic, this is the things. In exponential periodic boundary condition, this is like this. In parabolic, this is like this. So these are the average stresses in the body, in the RVE. Okay. Then the calculated Young's modulus, which through NSYS we have got. For exponential variation, the Young's modulus of the polymer matrix was 1.5 GPa. But overall nanocomposite is behaving like it is having the Young's modulus like 3.64 GPa. So we can see actual polymer matrix was having 1.5 and it is having 3.64. So this is the enhancement that we are going to get. Base polymer was having 1.5, but now we are getting more than we can say double Young's modulus, 3.64. So it is plus 142.87% increment in the Young's modulus in the case of exponential variation of the properties when suppose exponential variation is happening. Suppose parabolic variation is happening in the interface, then we are getting 228.15% enhancement. And with periodic boundary conditions, if we apply, then we are getting less improvement, 20% and 62% in parabolic case. Okay. So periodic boundary conditions are more realistic. So in reality, we will get lesser improvement. Okay. But still it is not less. It is quite big. 62% is not less. If we are getting 62% increment, it is not less. We cannot say it is less. Plus 20 is also not less. 20% itself is a big number. So this is the graph which we get from the NSYS after doing this analysis. How the stress and the strain are varying in this. The stresses are varying, stresses in this component. Okay. So you can see the stress. Likewise. So now the conclusion of this polymer nanocomposite case study is that on only adding 3% volume fraction, this is done only in a volume fraction of 3%. When 3% of particle is added, nanoparticles are added, then you can see what kind of enhancement we have got. At least 20 or 60% enhancement. Only 3% inclusion is added. So it will be very much means significant for the engineering applications. In engineering applications, we can by only sacrificing a little material or little cost, we will be getting a very higher properties. So that is the advantage of this concept of the nano phenomena. It is happening only because of nano phenomena, because nano phenomena is leading to enhancement in the surface area, and that's why we are getting this. Okay. So, and the main thing is that whatever desired properties we need to have, that is going to enhance. But it is not like that it is enhancing and some other property will deteriorate. It is not like that. Other properties will also not get compromised. Other properties will remain as it is, as these are. Okay, that is another advantage of nanocomposites. Other crucial properties will remain as it is. Okay, so it will be lightweight, obviously, because inclusion is having high density. That is a general thing, and the base material of polymer is having low density. If we are going to add only 2-3%, 5% inclusion, then obviously it is not causing so much heaviness, or we can say high density. Density will remain less itself, a little improvement only, and it will cause big improvement in the properties which we desire. And the nature of variation plays a big role. This is also a conclusion that how it is going to vary. As we saw that in exponential variation, we got 20% enhancement. In parabolic variation, we got 60% enhancement. So it also depends on how the interface is going to, means how the inclusion is going to interact with the polymer. So in different material combinations, it can have different kind of interactions. So depending on the different kind of interactions, different properties we can obtain. So various combinations of polymer and inclusion can have our different purposes solved. We can have this means it is not fixed that I have taken polypropylene and alumina. So that is one combination. We can go for another combination also, polylactic acid and some silica particles or silica nanoparticles, silica nanotubes. We can have different. I have taken nanoparticle. We can go for nanotubes also. I think all of you must have heard about carbon nanotubes, the undergraduate students. You must have heard about CNTs. Can you respond that? Can you raise your hand if you have heard about CNT, carbon nanotubes?
Oke, coba siapa yang punya itu produk
So
yang dibilang sama bapaknya?
anybody is raising the hands?
Not
If you have heard
really.
about
What is
carbon
the name?
nanotubes,
Can I repeat it again and
Yeah.
mention it to the student? The product of that you mentioned earlier.
Yeah, I said about carbon nanotubes. Have anybody heard about? Students have heard about carbon nanotubes.
Carbon nanotube.
Yeah,
Ayo,
carbon
apa pernah
nanotube.
dengar? Apa pernah dengar? Ada di mahasiswa?
Don't miss.
So if one of the any of the student want to tell, you can unmute yourself and you can tell.
Oke, sudah dipersilakan langsung oleh bapaknya. Jika ada yang mau menyampaikan pendapat, boleh unmute themselves ya. Kalau belum pernah dengar, bilang aja salah satu gitu.
Not Mister.
So I think they're not familiar yet with the term. I don't know. I'm trying to find the right word in our language in Bahasa Indonesia. They might be not familiar with the term in English.
Actually, carbon nanotubes are very revolutionary materials nowadays. Carbon nanotubes are creating a lot of state of the art materials. Because of carbon nanotubes, we are getting state of the art materials. Like we are getting very high improvement in the strength, and the weight is remaining the same. I think all of the students must be automobile enthusiasts, like racing cars, speed cars. All of you must be knowing these cars, Lamborghini, Ferrari, and all. Okay.
Yeah.
So these cars are having very high velocity. And if suppose these cars are made of metals, okay, metals, heavy metals, obviously we will get the metals strength if we are having heavy metals. But can they run in such high speed if they are having made of very heavy metals? Can any student tell me that if the car is made of very high end metal, means high density metal, because we need good strength, good things, good properties. That's why we are choosing the high density metal. So now can the Ferrari or Lamborghini car can run in 350 km/h?
Okay. Ada yang punya pendapat? Maybe I will try to translate it in Bahasa Indonesia, sir, first.
Okay, they are not familiar with English that much.
Yes, because English is actually not our first language here in Indonesia. So, but they know the basic English, but they just not using it as much as students in India.
I understand.
Yeah.
The similar happens in India also. Many students are well versed with Hindi. Hindi is the national language here. The means regional language here and national language as well. But many students are well versed with Hindi, but they are not that much good at English. That's very common thing. So
yeah,
actually, I was telling the students that automobiles are like these kinds of high end cars are made of if they are made of metals, heavy metals like titanium and other metals, then we will get the desired strength, but its weight will be very high. So weight will cause its velocity or its speed factor will get lost. Okay, we cannot get that speed in such high weight. Okay, so obviously we need to have a good strength to weight ratio for that kind of cars. So all the high speed cars need a very good strength to weight ratio. And the strength to weight ratio is tremendously achieved by this carbon nanotubes inclusion. If we are including carbon nanotubes in any polymer, then we get carbon fiber. That is also known as carbon fiber based material. Okay. That material is having very high strength to weight ratio. And the Lamborghini, Ferrari, and these kind of companies, Bugatti, Veyron, Volkswagen, these are using this material for manufacturing of the body of the car. So what are the advantages? What are the pros of these material? These, we can say, these are also polymer nanocomposites. The material which is going to construct the body of the car. Okay. So this is also polymer nanocomposite. So it is having very high strength to weight ratio. You can understand strength to weight ratio. Means strength is high, weight is low. Okay. That is the meaning of high strength to weight ratio. Strength high, weight low. So if the strength is high, that we need, because the car is going to run in 350 kilometers per hour. So obviously it should have strength in all the aspects very high. And weight should be low. Obviously, then only it will be running in 355, 400 kilometers per hour. So both the purposes are getting solved by the introduction or inclusion of polymer nanocomposite as a material for the manufacturing of the car. If we are going, we are not going for this material, we cannot go for the manufacturing of such high-end Lamborghini and Ferrari cars, which are running at 400 kilometers per hour at the speed of aeroplane itself. So it is possible only because of polymer nanocomposites. So that is the biggest, one of the biggest application of polymer nanocomposites. Okay, so these, this is the I just try to connect this polymer nanocomposite with the real time scenario, real time situations of the market. So this is like that. Okay, so that is the conclusion. Feature aspects, so many feature aspects are there. Okay, how means we can go for the different type of variations. We can explore the different kind of variations. We can do the experimental procedures. We can do so many things in the field of polymer nanocomposites. And obviously, it is the field of the era. It is being used in the world nowadays. So scope is infinite, because the scope is not going to end right now. It is a, we can say, smart material in the sense of better strength and low weight. And obviously, we are having a lot of scope to work on it still. So it is almost ended from my side. The presentation is almost ended. Actually, I just edited the presentation, but that was not edited. I have some more slides also. I was having acknowledgements, and that slide is missing here. So I just some technical error was there. I think because of that, it didn't get saved. So those slides are missing here. I was about to acknowledge some people also. So I will acknowledge them. So I will acknowledge the Department of Mechanical Engineering, GLA University, for continuous support for me here at GLA. They allow us for enriching so many things or enhancing our knowledge base. That's why I'm able to tell, share my knowledge here. Okay. Then I would like to thank the Professor Dilip Kumar Sharma sir, who is the Dean International Relations here in GLA University. And I would also like to thank one of my student. She is Miss Priyanshi Gupta. She has also helped me in my presentation. So I will also acknowledge her for this presentation. So it was a wonderful session with all of you, and I would like to have such kind of sessions in future as well, because I would love to have the interaction with the students. So only thing is that the language barrier might be there. So, but anyway, still we can have interactions in the future. I would love to have the interactions with the students, and I would also love to have interaction in the real sense, in the face to face in the coming time. Might be if Bhagwan Sri Radhe Krishna, you know Bhagwan Sri Radhe Krishna ji, Sri Radhe Krishna ji.
What is the meaning of that?
So
If
in
I
our
may ask?
area, Bhagwan Lord Sri Krishna, Lord Sri Krishna.
Ah,
So I worship Lord Sri Krishna like anything. So he can do anything. Means we can do anything with the help, with the grace of him. So if he will want, I think we can have a face-to-face communication as well in the coming time.
yes,
So
we
it
hope
was,
that as well.
yeah, it was a wonderful session, wonderful listening from all the audiences. And I think I was able to deliver whatever I want to deliver, but there were some glitches also, technical glitches, because of which I was not up to the mark which I should be. Next time I will
Yeah,
try to
no
improve
worries,
whatever
no
the
worries.
shortcomings
That's
were
a
there.
small problem. Then actually you fix it. So please don't worry about that.
So
So
now
thank
I'm
you.
open for any questions, any queries from anyone's side. I'm open for that. If
Okay.
anybody want to have any kind of questions, any kind of query, they can inquire that.
Okay. So first, thank you so much for your explanation on the polymer nanomaterial, which is, I think, is very interesting. And if I can sum up a little bit, so this particular material will help us if we want to develop a new material with lightweight, I think, and still have the capacity of strain that we want. I think that's something that I can catch from your explanation in this session. So
Correct.
we already have a question from one of our students here, if you don't mind. Bintang Pratama. Yes. Silakan Bintang.
Thanks for the time, Miss. And hello, Mr. Gaurav. My name is.
Yeah, hi.
Let me introduce myself. My name is Bintang Pratama. I'm a second year student in Mechanical Engineering Education Program. Please allow me to convey my question. First, I want to ask, will this technology of polymer nanocomposite is eco-friendly and energy efficient? The second, I'm little interested to study nanocomposite, but there are many things that I don't understand from your explanation because it new experience for me. If I want to learn it from basic, are there any reference that I can use to study such a book?
References. Yeah, actually, I will tell you the references. I can tell you. You can note down my mail ID. I will share in chat box. I think I can share in the chat box my mail ID. If you can have further communication, we can have the communication in the mail ID. I will share the mail ID here. So let me just.
So Bintang, Mr. Gaurav is very kind to give his email address to you. So if you have some questions specific to
I'm
polymer
unable to find the
nanocomposite,
chat tab. I'm unable to find the chat tab. I'm typing the slide. In the slide, I'm typing the mail ID. Just wait. So you can have if any query you are having, you can have in the future also. I'm just typing here the mail ID of mine. So it is gauravpant.me@gla.ac.in. I think you are able to see this mail ID.
yes, I will text that back to my
This mail
student.
ID, you can have the communication and further if you want to have any communication or any information, whatever I can convey to you.
Thank you very much.
Thank you so much. Anybody else who just want to ask anything?
Okay, next question, maybe. Also, Mr. Gaurav, actually, our coordinator of study program, Mr. Pase, already sent his question through chat, to private chat to me. So maybe I will read his question for you if that's okay.
I think Dr. Novia has taken the snapshots.
I did. I already take a screenshot of your email.
Fine.
Okay.
Fine.
So we have some question here from Mr. Pase, one of our faculty member. So the first one is, what are the potential nanoparticles currently being developed to make polymer nanocomposite materials?
Potential nanoparticles.
Yes.
So it depends on the application. For what application we are going for the nanoparticles, like carbon nanoparticles might be there. We can have alumina nanoparticles, silica nanoparticles, and many more other nanoparticles which are having good properties, better properties. We can go for that. depending on the situation, at what situation, what kind of application we need to have.
Okay, Mr. Pastor, so it's based on
Even
the
in medical
application.
sciences, gold nanoparticles are used in medical field. Gold nanoparticles are means some therapies need gold nanoparticles also. So that is going to cure us, cure so many of ailments of us. Gold nanoparticles.
Okay, so we have a automotive concentration here. If the application is for motor vehicle body framework, so what is the kind of nanoparticle that can be used for that purpose? So,
For what purpose?
for the motor vehicle body frame, the body
vehicle
frame of
body.
the yes.
For vehicle body, carbon fibers, carbon nanotubes, these are best suitable. Carbon fibers, carbon nanofibers, carbon nanotubes, carbon nanoparticles. That enhances like anything.
Okay, Mr. Pastor, do you have any more questions, or the explanation is enough? If Mr. Pastor still joining this class, okay. Next question maybe from other participants. Okay, Bintang,
Somebody has
another
raised a
question.
hand.
Okay, Bintang, another question.
Bentang has raised a hand.
Yes, go ahead, Bintang.
Saya Ari, Bu. Saya di sebelah Bintang. HP saya mati.
Okay, so this is our student Ari using Bintang's account. Want to ask you some question because he have technical difficulties with his device, so he used Bintang account to ask. Yeah, Ari, go ahead, please.
Okay, thank you for the time for me. I have a question. Is can nanocomposite provide benefit in technological development in the future? Thank you.
Please repeat once.
Diulangi lagi, Bu Ari.
Can nanocomposite provide benefit in technology development in the future?
Yeah, definitely it is going to contribute in the technology in the future, and it is the material of future itself. Right now it is being evolved, it is being explored, and it is being researched, and in future, in the coming time, in the coming 50 100 years, it is going to come in the large scale in so many things. Nano materials will come, and it is the era of nanotechnology. It is just started. Nanotechnology has started, so it is the limit is sky is the limit. So many things are going to have in the coming 50 100 years. You will see these things in the coming time.
Okay, Ari.
Sir.
Have you got the answer, Bintang?
Okay, Bintang, Ari. Okay. Or do
Siap,
you have
aman.
more question?
Siap, aman, Bu.
Okay. Any more questions from the student, or probably?
He has got or
from
not?
our
Bintang has got or not?
faculty?
Answer.
I'm sorry?
Bintang has got the answer or not?
He said
Yes.
yes.
Okay.
He replied in
Fine.
Bahasa Indonesia. We're sorry. So he got the answer.
Fine. Thank you.
Okay. Another question maybe, is it possible for coming from the faculty member or the students? So I think it's interesting that the research of the nanoparticle is still developing now. So maybe for the faculty member that plan to get their doctorate, this is one of the topics that they can get for their research, I think. So this might be open a probability for us to discuss again, Mr. Gaurav, in the future. I would very much like to invite you in our discussion with our faculty member, and I know that some of them are very interested in material sciences and also wants to take their PhD in that area. So I think this discussion will be benefited so much for our faculty. So I will contact you through your emails or maybe from Mr. Delip as well. Yeah, we can discuss the next interaction that we can do. Maybe we can make another guest lecture series.
Yeah, sure. Sure.
Yeah, we break down the material again. I think that we will do in the future. Okay, if there is and not, okay. One more time, I ask, do you have any more questions?
Okay.
Okay, Pak Wiratmaja is one of our faculty member. Sir, go ahead, Pak.
Okay, thank you, Miss Novia. Good morning, Mr. Gaurav. Nice to meet you, sir.
Yeah, hi, sir.
Warm greetings from the Mechanical Engineering Education Undiksha. Yeah, maybe my question relate about the polymer nanocomposite material. How about the impact testing, sir? That's linear with the tensile testing or the modulus elasticity or modulus Young. So we have the student here, mechanical engineering education. The focus for the research in the last semester is about impact testing for the composite, combined with the combined with natural fiber with the polymer. And I need your opinion, based on your research about the related impact factor, safety factor, impact testing, and tensile strength for the polymer and the composite materials. Please, sir. Thank you.
You want to know how to do the impact testing?
Impact testing to test the body, check the body strength, of the maybe the material used for the body of vehicle. In Undiksha Mechanical Engineering, firstly, I do the impact testing firstly for the material.
Correct.
Yes. Yeah. Maybe you can bring some information about the how real relationship about the impact strength and tensile strength in the polymer and the composite materials. Is there linear or not? Maybe, please. Maybe you can bring
Impact strength
information.
Once we fabricate the polymer nanocomposite, we go for that fabrication. Then we can go for the impact testing also in the NSYS itself. We can do the we can input the parameters for the impact testing. Whatever the impact testing is sudden load, so we can apply the parameters like as the simulation of the sudden load in the particular specimen, and then we can see what are the outputs coming for the impact test in the NSYS platform. Or otherwise, we can go for the fabrication of the real specimen, and then we can go for the impact test, and then we will be finding what kind of results we are getting for the impact test. And we can even do the comparison between the real results and the simulated results in the NSYS. And we can see how much variation is there in the results of both the things. So we have to do some simulation and experimentation. Then I think we will be able to understand that how much enhancement is coming in the impact strength on mixing particular kind of like carbon fibers, carbon nano composites. If we are going to fabricate, then we will get the impact strength. Obviously, it will be enhancing. Impact strength will be enhancing. That is very obvious. It will not deteriorate. It will enhance itself. But how much enhancement is happening, that we have to measure. We have to gauge. We have to check.
Mr. Wiratmaja, does that answer your question? Or do you have any more questions for
Yes.
Mr. Gaurav?
Okay, I think that's enough, sir. Thank you. Thank you for your permission.
You're welcome.
Okay, thank you. Bagus Dharma, do you have some question? Because I see you raise your hand before.
Maaf
Do you
Bu,
have some
kepencet.
question for Mr. Gaurav?
Tidak, Bu. Maaf, Bu. Kepencet tadi.
Okay. Well, since you raised your hand, you really don't have any question for him? He's available for you right now. Okay, I think that's it for the Q&A session, sir. So by that, then this lecture is coming to end. So once again, I would like to thank Mr. Gaurav Pen for his availability today and giving us such a exciting material today in this lecture. And also, like I said before, that in the future, we will have another discussion about this topic, or maybe another opportunity for the guest lecture for another topic maybe. For Mr. Gaurav, do you have any question for us? Maybe?
For sure. I would. It's my pleasure to have discussion with all of you, and it will be my pleasure again in the future to have interaction with you guys in the coming time related to mechanical engineering or material sciences and all. And I just want to ask one thing. It is the name of the university is Ganesha University.
Yes, Ganesha University of Education.
So Ganesha is our Lord Ganesha in Hinduism. He is a Lord.
Yes,
So
in Bali.
there is so much dominance of Indian scriptures in Indonesia. I have seen. I know.
Yeah. So
So that is
majority
also
here, people are also practice Hinduism. And I think the name of Ganesha University were formed in that direction as well. Because he is the god of the education, if the thing that we believe in here in Bali, that can guide us with the new knowledge and everything related to that. I think that's one of the main reasons why we choose the name of Ganesha University of Education as our name for our university.
okay. It is inspired by some Hinduism also. I think this university.
Yes. Yes.
That's wonderful. That's wonderful. So I would like to have a real time means interaction there sometimes if the future allows us.
Yes, if you can visit us here in our campus in Bali, that will be wonderful. Or we can go to your university maybe.
Yeah, you are also welcome to our university, GLA University, Mathura. Mathura is the birthplace of Lord Krishna, where this university is situated. So it is having very high mythological value in this place where I'm sitting right now. It is considered as one of the best place in the world in Hinduism, Hindu mythology. It is the one of the best place in the world. So I'm proud to be sitting here right now.
Yes, it's very interesting, and we definitely want to visit you there. So maybe we can arrange that later with our vice dean and our dean here. So maybe we will very much soon communicate with each other again. Okay, thank you so much once again for Mr. Gaurav for
I will also share my number so that you can share the images to me on WhatsApp also. No?
Yes, I will send
because
you
I
the
will need the images instantaneously. In email, it will take some time. This is my number. Please share the images to me. And if you are having the recording of this, can you please share the drive to me in my mail ID? If the recording of this session you are having.
Okay. After this session, I will send you the photos and also the link for the recording.
Yeah, so I would like to thank University of Ganesha, Dr. Novia, and head of the department, and so many dignitaries present over here, and the dear students. I would like to thank you, all of you, so that you listened very carefully and asked your queries. So it was an enrichment in my I would say it's an enrichment in my teaching today. So
thank you so much. It's such a pleasure to have you with us today. Maybe I want to take a picture together with all of the participants here today.
Yeah, you can take a group photograph also. All can turn their camera on.
Okay. Okay, semuanya silakan buka kamera. Okay, I will count to 3. 1, 2, 3. That is the first page. I'll go to the next page. Okay, 1, 2, 3. The next page, we have a lot of students today, which is good. Okay, 1, 2, 3. Okay, one more. 1, 2, 3. Yes, I think I captured all of you guys. So thank you so much again for coming to this lecture. And you can leave the Zoom room today. Thank you so much.
Thanks a lot. Now
Have a
I
good
think we can
day.
sign off. And please
Yes.
share the photographs to me
Yes,
on
I will.
my WhatsApp.
Yes, I will. Thank you so much.
Thank you. Thank you. Namaskar. Namaskar. In
Have a
India,
good day,
namaskar is the
everyone.
way to salute.
Thank you, Mr. Gray.
Namaskar. Namaskar, Mr. Gaurav.
Yeah,
Nice,
namaskar.
nice. Yeah.
Thank you so much, all of you.
Okay.
Thank you, thank you.
Thank you.
Thank you, Mister.
Thank you.
Thank you so much.
Welcome. Welcome.
Thank you, Mister. We love you.
We can also take a print screen. No? So print screen, then we have to. Yes. As they will be sending. This has come here, I think. It will be saved. I need to take a video. I have to go to.
Thank you, Mister.
Okay, I'm leaving the meeting. Thank you so much again. Radhe Radhe.
Assalamualaikum.
Om Swastiastu.